everybody, recording has started. Okay? One thing you may notice if you're at home watching or if you're here in class watching, the cursor blinks while it records. So if you're one of those like OCD people, sorry. The next like 25 minutes are going to be like hell for you, okay? But anyway, yesterday we got into this idea of measurements. So the first thing we introduced on the measurement side was, why is it important that we come up with this system of measurements? Why is it important that we measure or all come up, we have this like consistent system that we use to measure things? Why? Bartek. If everyone used their own tools to measure things, do we all end up with the same answer? No, and that's kind of a problem, especially if we're looking to reproduce results, or if we're looking to do an experiment over, or if we're trying to get something that we measured in one place the same somewhere else. So we have to have this system that goes along with the measurement to make sure that we're all measuring the same way. We talked about base units, and we said there's certain things we can describe with basically one measurement. Those are our base units. But then there's some things that we can't describe just with one measurement. We call those derived units, where we have to basically measure two things to describe what we see out there in nature or whatever it is we're trying to measure. Towards the end of class yesterday, we talked about units, and I hope we don't have to spend time on this slide, right? Why do we need units? Because we got to know what we're talking about. And I believe right at the end of class yesterday, we finished off with this slide. Is that correct? Certain digits versus uncertain digits?
No.
And you guys just get this far.
We're on.
All right, let's go there. Every measurement that we take in this class, but not just every measurement that we take in this class, every measurement that any scientist out there takes has a certain degree of uncertainty. There are parts about a measurement that we know for sure. Then there's other parts that we're guessing. Why are we guessing? Well, we'll talk about why in just a second. But every measurement that's out there has two parts. A certain part, things that we know for sure. But then, like I said, every measurement out there has an uncertain part. We refer to it as an uncertain digit. There's a part as to what our best guess about the actual value of that measurement is. Something that a lot of you, or some of you, might not like. There is no such thing as an exact measurement. It doesn't exist. There are limitations in the way that we measure stuff. And because of those limitations, we end up not being sure about a couple of things. And we'll talk about those things today, why we're unsure about those things, and how we deal with that. So there is no such thing as an exact measurement. There's always some uncertainty involved with it. Good there? Are you ready to get down to the nitty-gritty? Okay, well, too bad. Flip it over to the back side. Once you've written what's on the front side. Up on the top left of the back side, there is a picture of this ruler. Now, your picture of this ruler, there is a picture of this red line. Before we talk about anything involved how to measure stuff, I want you to guess for me. On your sheet, right above that ruler there, just jot something down real quick as far as what you think the length of that red line is. What you think the length of that line is. Next, the picture that's right next to it. The picture that's right next to it. There's a different ruler. You'll notice on the far end, the far left over there, that's not the beginning of the ruler. The ruler starts all the way back at 0. We're just like zooming in on one part of it. And then this red line started all the way back at the 0 mark on the ruler that we're not seeing, and it ends up here. So, again, your best guess as to the length of that red line. If I ask you how long that red line is, you write down what you think it should be. All right, we got our guesses? Okay. Now, let's talk about measurement technique. Here's our original red line. According to this picture, there are two things that you can tell me for sure about that red line. Absolutely, positively that you know. Katie, what's one thing you can tell me about that red line?
It's between 5 and 6.
So that means that it's small, or it's bigger than 5 centimeters, and that means that it's smaller than 6. Those are the two things you can tell me for sure. That's it. Based on this ruler that I am giving you to work with, you can tell me two things. Bigger than 5, smaller than 6. That gives me the certain part of my measurement. Remember I told you before, measurements have two parts, a certain part and an uncertain part. That gives me the certain part. But if I just record my measurement as somewhere between 5 and 6, that leaves kind of a lot of room in here, right? That's kind of a big area. You know, what if it's way over here? Or what if it's way over here? Those are two very different measurements. So we have to do something to make it a little bit better than just between 5 and 6. That's where the next part of our measurement, our uncertain part, comes in. The uncertain part of our measurement is our best guess as to what the actual value is. To me, it looks like that line is about 70% of the way between the 5 and the 6. So I show that as 5.7 centimeters. Some of you may be looking at this and thinking, Mr. Klasek is clearly not qualified to do this, because that red line is obviously 80% of the way between 5 and 6. I'm looking at it. It's clearly 80%. So you would make your best guess as 5.8 centimeters. Is that a problem? Like my best guess and your best guess are different? No. That's not a problem. Why? Because like I told you before, there's no such thing as an exact measurement. There's always some degree of uncertainty. This last digit, the uncertain digit, we understand to be a guess. My guess is 7. Your guess is 8. That's fine. When we look at things on a test, if I ask you to write down the length of this line, if you write down 5.8, you're not wrong. If you write down 5.6, you're not wrong. If you wrote down 5.2, I might give you a little bit of argument with that. I think it's definitely farther than 20% between 5 and 6, right? But that last value is what you see it as. So it might be different from one person to the next, and that's okay. Good there? Okay. Back to this picture. There's that line again. No, it's a different line. Okay. What's changed from the previous picture to this picture? Still good. Okay. Our ruler has more lines on it, right? Okay. Now we're marking the 0.1, 0.2, 0.3. Based on that information, two things you can tell me for sure about the length of this red line. What can you tell me for sure about this red line? Max? It's bigger than 7.7, less than 7.8. And I can tell that for sure because of the marks on the ruler. That means now, instead of having one certain digit, I have two certain digits. How come I have two certain digits in this value instead of just one in the last value? Man, because the ruler changed, right? There's more lines on the ruler. That gives me more certainty. However, just like on the last one, I can't just say somewhere between 7.7 and 7.8. There's a lot of room in there. What's my best guess as to where it actually is? To me, looks like about 20% of the way. So I would record that as 7.72, with the 2 being my best guess as far as where it actually is. What if you write down 7.73? Are you wrong? Nope. What if you write down 7.71? Are you wrong? No. All of those are correct answers. Okay? That's fine. Okay? Now, let's do one more slide, and then we'll talk about where some of you went. Like we said before, each measurement has two parts. There is a certain part. The number of certain digits in your measurement is going to change depending on what? What caused the change in the number of certain digits in our two measurements that we took before? Lily. The ruler that we use. So based on the measuring tool that we use, I will say ruler in a general sense, but it could be a ruler, it could be a balance, it could be a graduated cylinder, whatever. The number of certain digits that we have in our measurement changes depending on the ruler that we're using. However, there is always only one certain digit. There is always only one uncertain digit. My bad. That uncertain digit is our best guess as to how far it is between the two lines that we know for sure. So, number of certain digits is going to vary depending on the measuring tool that we are using. Number of uncertain digits is always going to be the same, 1. Good there? Got this written down? Close. Okay. If you're watching at home, stay by. Maybe go to the bathroom real quick. I don't have enough time to go to the bathroom, really, but I gotta open up another program because I forgot to open it first. So you get to see this like real time. So, I could go and edit it out, but who's got time for that? So. Okay. Take this. That's not what I wanted to do. Alright. So before, when I asked you to make your best guess as far as the length of this line, some of you keenly noticed that on the board next to the screen, which if you're watching at home you can't see right now, but on the board next to the screen, I had this written. Okay? Honest show of hands. How many people wrote 5.75? Okay, in an honest show of hands, how many wrote 5.75 just as I had it written on the board over there? Okay. Here's what I want you to do. I want you to take 15 seconds. And I want you to talk to the person in front of you, behind you, next to you, whatever. And I want you to discuss how come 5.75 is not an acceptable answer for the length of this red line that I'm showing you on the screen right now. 15 seconds. Why is 5.75 not an acceptable answer? Don't talk into the microphone. Go.
Because there's two uncertain digits. There is two uncertain digits, Maddie. I see two uncertain digits.
Yeah, we don't measure.
Wanted to scream it into the mic.
Okay, let's discuss. I know why you guys wrote that it was 5.75. How come you wrote that it was 5.75? I didn't say it was. You guys said it was. I didn't say that. I wrote it on the board, okay? For those of you that didn't just copy it off the board, why did you write 5.75? Savannah. It looks about 3/4 of the way between 5 and 6. And from math class, you know that 0.75 is 3/4 of the way. 5.75. How come the answer can't be 5.75? Nicole, go ahead.
Because there's two uncertain digits.
There could be two uncertain digits, or, okay, if I write 5.75, and let's say I know how to read a ruler properly, okay? If I write 5.75, I'm trying to tell you something about the length of my red line. What am I trying to tell you about the length of my red line if I write its length as 5.75? Men?
It's 3/4 of the way to 6.
That's not what I'm trying to tell you if it's 5.75. If I write 5.75, what am I trying to tell you about the length of that red line? Please go ahead.
It's 5. I want to say, like, the next decimal place over only counts as, like, it's 100th and then a 10th.
Yes.
I can't.
You want somebody to
use my
help?
words.
You want somebody to
I
help?
know what it means.
Okay, so let's see if we can have somebody see some verbalize it. Keenan, go ahead. You shied away. You were up there for a while, and then anybody else? What is 5.75 trying to convey to you? Okay. Nicole. So, Nicole.
Yes.
You said that if I wrote 5.75, that would mean that there were two uncertain digits, and I said, not necessarily. Elise, do you want to try again?
It's like 5 centimeters and 7.5 tenths centimeters.
Meh. Keenan, you want to go again?
Trying to show exactly.
Yes. Well, but I can't show you the exact location, though. There's something else. Sarah, go ahead.
Is there like one uncertain digit?
There can only be one uncertain digit. There can't be two uncertain digits. So if that's the case,
One of them is certain.
which one's certain?
5.
No.
Oh,
Well,
7.
this one's certain.
Well, I knew that.
And that's a yellow highlighter that shows up on blue. It just doesn't look very good. Okay? And then this one is certain.
Okay, then I said the 5 was.
Okay?
5 is uncertain.
This 5 on the end is uncertain. But if the 7 is certain,
How do you know that?
No, the 7's not certain.
now if I write 5.75, it is. And how come that can't be the case on this ruler? Katie, go ahead.
Because it doesn't show the tenths.
Good. If I write 5.75, I'm trying to tell you that that red line is halfway between 5.7 and 5.8. But what's the problem with that measurement on this ruler? Bucket.
Our ruler doesn't have those increments.
I don't know where 0.7 and 0.8 are. 5.75, being that there can only be one uncertain digit, That means, because you said it before.
Well, yeah, that's what I said. I said there are two uncertain ones because you
No.
can't know that the 7's there.
Well, if I write this, right? Okay, is that what you meant?
Sure.
Yeah.
I don't.
Yes, that's what I
wait,
meant.
I
So, I can't write 5.75 for this measurement because I don't know where 0.7 is and I don't know where 0.8 is.
Yeah, that's it.
Same thing here. If I go with this, some of you would have written down 7.725. I know why you wrote 7.725, because it looks like it's a quarter of the way between 7.7 and 7.8. But this measurement is not telling me it's a quarter of the way between 7.7 and 7.8. It's telling me it's halfway between 7.72 and 7.73. And that's a problem. Why? Do I know where 7.72 and 7.73 are? No. Okay? Good there? All right. Let's see if we can do this real quick. In the bottom left-hand corner, there is a picture. In the bottom left-hand corner of your handout from yesterday, there is a picture of this. This is a balance. Okay? You slide the little slider bar, and it ends up right here. Talk to the person next to you for 15 seconds. What's the proper measurement of this mass? Go.
There will be no eating in the senior hallway tomorrow. Mr. Egan, Mr. May, and Mr. Duggan will be checking each lunch period. And please also clear the halls for visitors, students, and staff so they can get through properly. Thank you, and have a great day.
said there was two things, so that's what was wrong with it. There was two
Okay. Do you understand where you understand? I think we're doing the same thing. We just described it. Okay. All right. Hey, let me finish this real quick. This is, so over here, 7.1, 7.2 is here. Even though we haven't labeled all these lines, they're still there. So each one of them represents 0.01 grams. 7.10, 7.11, 0.12, 0.13, all the way up to 0.2. Does that make sense? One more. That's good for now. So do this for me. Here's your sheets. Here's your sheet that I gave you yesterday. There's a couple that I don't want you to try tonight. They will confuse you. You're not ready for them yet. Underneath the rulers, you should be able to do all of those arrows. A through E should be okay. On the graduated cylinders, don't try number or letter D or letter F. Don't try those just yet. Okay? And then on the thermometer, don't try B just yet. Okay? On the back, the balances, you should be able to do all of those. They're a little confusing, but it's some addition. Okay? The bottom one is the bottom row on the balance, the one you're going to read. The rest you add up. Okay? Give it a try tonight. We'll talk about it in class tomorrow. Good job with the recording, everybody. We'll try that some more.